be talking about electric charge. In this lesson, we're going to discuss positive and negative charges, know how charges repel or attract, and simple experiment to show the production of electrostatic charges by friction and how to detect them, and explain the charging of solids by friction, and an experiment to distinguish between conductors and insulators. Let's start by what an electrical charge is. All objects may have positive or negative charges. If they are like charges, they'll repel, and if they're opposite charges, they'll attract. A charge itself is measured in coulombs, which we write as capital C. Electric charges are what create an electric field in surrounding areas. The region between an electric charge experiences a force, which is known as an electric field. The field lines will always move away from the positive charge and go towards the negative charge. Electrons are negatively charged particles. So the negative charge will gain the electron and the positive charge has lost an electron. Induction. When a charged material is brought near an uncharged material, it induces a charge in the uncharged material. So let's look at the negatively charged rod near an object. What will it do? It will attract the positive charge towards itself, and the negative charge will gather on the opposite side. So the positively charged rod will attract the negative charges. Insulators and conductors. We know that conductors are materials that allow charge to pass through. They have a pool of delocalized free electrons that move to transfer the charge, and the electrons can move around different atoms like copper, gold, iron, and so on. Insulators, however, do not allow the charge to pass through. They do not have free electrons to transfer the charge, so they cannot conduct electricity like rubber, plastic, and wood. How can I charge a solid by friction? When I have an uncharged cloth and I rub it against an uncharged polythene rod, the electrons are transferred away from the cloth to the rod. So this way, the cloth has lost electrons, so it becomes positively charged, because we said if you lose, you become positively charged, and when you gain, you become negatively charged. And the rod itself has taken or gained electrons, so it became negatively charged, and eventually they'll attract each other. When an uncharged cloth is rubbed against an uncharged acetate plastic rod, same thing, the electrons will be transferred away from the acetate rod to the cloth. The cloth would have gained electrons, becoming negatively charged, so the rod has lost electrons, becoming positively charged, and they'll eventually also attract. So how to demonstrate electrostatic charge? The aim of the experiment is to investigate how insulating materials can be charged by friction. I'll use a polythene rod to charge and hang from a cradle to test against each material. I'll have rods with different materials like acrylic, acetate, glass, and wood. I'll have cloths, one per material, to rub the materials to charge them, the cradle to suspend the rods from, so they can move freely, a nylon string to hang the rods, and a wooden stand to suspend the string and the cradle from. Here, the things that I'm changing, which are my independent variables, are the rods of different materials. What is the thing that I'm measuring, which is the dependent variable? The charge on the rod. What are the variables that I'm controlling? How much time was spent rubbing the rod, using the same type of cloth, using the same length of rod. So I'll take the polythene rod, hold it at its center, and rub both ends with a cloth. I'll suspend the rod without touching the ends from a stand using a cradle and nylon string. Take a second polythene rod and rub one end with a different cloth. Bring the second polythene rod close to the suspended rod. Record any observations of the suspended rod's motion, whether it got attracted or repelled or didn't move at all. And repeat using an acetate rod and rods of different materials as well to compare. So the analysis of the results. When two insulating materials are rubbed together, the negative charge electrons will transfer from one insulator to the other. So the polythene rod will gain negative charge when rubbed with a cloth because electrons are transferred to it from the cloth. An acetate rod will gain positive charge when rubbed to the cloth because the electrons were removed from the acetate by the cloth. So reduce the effects of environmental factors to ensure motion of polythene rod is due to electric force only. Make sure not to touch ends of rods once they've been charged, and produce greater deflections by rubbing the rods for a longer period to transfer more charge. Here's another experiment, detecting charge using a gold leaf electroscope. The independent variable will be rods of different materials, and the dependent will be the charge on the rod. First, I'll start by ensuring that the plate of the electroscope is uncharged by touching it with your finger, so any charge would move to you. The leaf should hang straight down next to the stem. Charge the polythene rod by rubbing it with a cloth and bring the charged rod towards the plate of the electroscope and record any observations. Now bring the charged rod away from the plate of the electroscope and record any observations. Touch the charged rod to the plate of the electroscope and record any observations, and repeat using an acetate rod. So when the charged object was brought near the plate of electroscope, the leaf rises. And when the charged object is moved away, it falls. And when the charged object touches the plate of the electroscope, the leaf stays risen. And when a finger touches, immediately all of the charge would go away, so the leaf falls again. So what you need to do to make sure that the experiment is going right is to make sure not to touch the ends of the rod once they've been charged. And when the electroscope is charged by contact with the rod, it should stay risen. If it doesn't, then repeat the process to make sure that there was no charge from before. Thank you and have a lovely day.